Hi everybody, today I'd like to talk to you about parabolas, and this is a special request I got from a student asking about changing from vertex form to standard form and of course solving. So I'm going to start off with a parabola in vertex form, and you'll see this is y equals negative x minus 2 quantity squared plus 3. And the first thing that you'll notice is the negative out in front, that leading coefficient of -1, indicates that the parabola is going to go downwards. And then the next thing that you'll see is that since this is in vertex form, we can pull out h and k, and the vertex is going to be at 2, 3, which is what we call the local maximum in this problem. So here's my graph. And I put the vertex at 2, 3, and this parabola is going to go down like that. Hasn't been stretched or squished. And one of the next things I like to do when doing parabolas is I like to indicate what the x and y intercepts are. So the first thing I'm going to do is I'm going to find the y-intercept by letting x equal 0. And you can plug in x equals 0 really to any form, factored form, vertex form, standard form. It doesn't matter. So when I let x be 0 and I simplify, I get the value of y equals -1. So I know that this parabola is going to intercept the y-axis at 0, -1. Okay. The next thing I'm going to do is I'm going to change from vertex form to standard form. And the way I'm going to do that is I'm going to multiply everything out. I'm going to multiply everything together and simplify. So you can tell the x minus 2 quantity squared needs to be multiplied by itself. And I'm going to do what they call foiling, but it's just distributing those binomials together. Then you'll also see that I have taken that -1 and multiplied it. Finally, I added the 3, and I get y equals negative x squared plus 4x minus 1. And so that right there is what we call standard form, and we can see the a, b, and c terms. So next, we're going to find the other intercepts, the x-intercepts, now that we already know what the y-intercept is, or we're going to find the roots. And first I'm going to find them using standard form, and then I'm going to find them using vertex form. So I'm actually going to find the roots twice. So in standard form, typically the way that we find the roots are we're going to let y equal 0, and we can either choose to factor if this is easily factorable, or if it's not, we'll use the quadratic formula. And since it's not easily factorable, we're going to go ahead and use the quadratic formula. And so here's the quadratic formula. We should know that as -b plus or minus the square root of b squared minus 4ac divided by 2a. And by plugging in all of our a, b's, and c's into the quadratic formula, we see that we have this situation. And all that needs to do is we just need to start and simplify what we have. So notice, just step by step, following the order of operations, I end up with 2 equations, and I'm going to need a calculator since the square root of 12 happens to be irrational. And notice, by using a calculator, I end up with one root being at about 3.73 and another root being at about 0.0267. And on my graph, I can see that's approximately where those roots would be. Okay, so we found both roots, or the x-intercepts, and we also found the y-intercepts. So next I want to show you how to find the same thing, those roots, but this time using vertex form. So it shouldn't matter to us finding the roots in either form. We're always going to do the same thing, and that is we're going to let y equal 0. And so I went ahead and let y equal 0 in vertex form. And so we're going to go ahead and simplify in this case. First I'm going to move the 3 over to the other side. Then I'm going to multiply both sides by -1, making those both positive, and I'm about to take the square root. When I do, I have a plus or minus square root of 3, and then I'm going to move the 2 over to the other side. And so I have two roots, 2 plus square root of 3 and 2 minus square root of 3. And again, I'll need to use my calculator since the square root of 3 is also irrational. And look at that. I get the same two roots as I did before when I use the quadratic formula. So you really are just going to choose the one that you like to use the best, because it doesn't really matter which one you use to find roots. Use the one that's easiest for you. So right there, those are the two roots. And by the way, something you might have noticed, and that is the what we let x be using the quadratic formula and what we got x to be using solving in vertex form, those are equivalent. So -4 plus or minus the square root of 12 over -2 actually reduces to 2 plus or minus the square root of 3. So that's kind of interesting for us. And so those are the two roots, and we have our y-intercept, and so now the parabola is solved for us. Awesome, great job.